Oxidation of aldehyde and ketone. We know aldehyde oxidized to give acids, that is carboxylic acid. So which aldehyde we are taking, correspondence acid will get. For example, here you can see if you are taking acetaldehyde, we'll get, if you are using acetaldehyde, we are getting acetic acid. So this oxidation is occurring by using strong oxidizing agents such as sodium dichromate and KMnO4, potassium permanganate, that we can use. And there is a very important test for aldehyde and ketone, that is tolerance test and Felling's test. It's a very important test for identification of aldehyde and ketone. This test are using to identify aldehyde and ketone. Then we'll move to the naming reactions. First one is aldol condensation. So it is a condensation reaction. So condensation means addition. It will move to alcohol. We'll get alcohol. So for example, the reaction of an aldehyde or a ketone with dilute base or acid to form beta hydroxy carbonyl product. So what do you mean by beta hydroxy? Beta hydroxy. So we know what is alpha hydrogen, beta hydrogen, etc. So what is alpha hydrogen here? So the carbon which is attached to the functional group, that is alpha carbon. So here this carbon is known as alpha carbon and this hydrogen is known as alpha hydrogen. So which is attached to, if there are more carbon attached to this that we can call as beta carbon and beta hydrogen. So similarly, if in this reaction we'll get beta hydroxy carbonyl product. So here you can see that. Here we can get, for example, here this alpha, this beta. So we are getting beta hydroxy. Here a hydroxyl group will form in the beta position. So here you can see they are taking two ketones. If two ketones are combined each other, we'll get beta hydroxy carbonyl product. So the C double bond of one ketone will remain same, and to the one carbonyl group the addition of H plus, addition of hydrogen occurring. So that's why we'll get the compound. Here you can see another example of similar to aldol condensation, that is nucleophilic addition reaction by enolate ion. This is known as enolate ion, that is ONA. So here you can see the OH minus, that is NaOH. In this OH minus will attach the compound. So it is OH group having minus charge. So one hydrogen from this will absorb by OH minus. So we'll get CH2 minus CH double bond O. So this is a step. So the first ketone, here we can see it is in the acetaldehyde reaction. So from this aldehyde, so this aldehyde carrying negative charge, so this negative part of this aldehyde attack the second aldehyde. So that we are taking two aldehydes, so it will attack here, so the bond will shifted here. So this O will carry negative charge in this step. So again the hydrolysis occur. So we'll get the compound. So OH will get our compound. This is the reaction here. This is the mechanism of this reaction. You can see here aldehyde. So we are taking two aldehydes. So how this two aldehyde couple, that is occurring here. So in the presence of dilute NaOH, the reaction is occurring. That is OH minus will there. First OH minus will attack here. So minus one hydrogen will taken by this. So what will happen? So the minus charge will attack here. So minus charge will produce here. So the minus charge attack the second aldehyde for in order to get stabilization. So the bond will shifted here. So to the O minus, the H plus will attack and will get to the compound. Here the reaction of ketones are there. That there we have seen that the aldehydes, if in the case of ketones, similar process, OH minus will attack to the terminal carbon which having hydrogen. So it will absorb one hydrogen and form H2O, and we'll get the second step. So it became CH2 minus, and CH2 minus, this minus charge minus part of carbon will attach the second ketone. Similar process, the bond will shifted here. So O minus, so H plus absorbed by this, or H plus CH3, any group we can absorb. We'll get the compound like this. This is the reaction. Then crossed aldol condensation. If you react, there we can see we are taking 2 aldehyde or 2 ketone. Here we are taking 2 aldehyde or ketones together in a aldol condensation. You will get 4 products. So if you are taking 2 ketone, 2 aldehyde, will get 4 products. If you are taking the reaction, if there is no alpha hydrogen containing compound, will get a compound which having alpha hydrogen. This is known as crossed aldol condensation. Here you can see that we are taking an aldehyde and ketone. Will get crossed aldol. It can be also done by an aldehyde and a ketone yield one product. Also, this is an ketone, that is acetophenone and acetaldehyde. The presence of any base will get crossed aldol. This is a crossed aldol. The next reaction is Perkin condensation. This reaction is Benzaldehyde react with acetic anhydride in presence of sodium acetate to form cinnamic acid. This is cinnamic acid. This compound is known as cinnamic acid. So here we can see this is acetic anhydride. This is acetic anhydride. So acetic anhydride, this is acetic anhydride. This compound is known as cinnamic acid. Acetic anhydride. The first step is, this is the structure of this compound. So it is having a negative end. So it will attack here, bond will shift it here. We'll get this type of compound. And from there, it will produce cinnamic acid. This is the reaction of benzaldehyde with acetic anhydride. The presence of sodium acetate, which gives cinnamic acid. The next one is benzoin condensation. Benzoin condensation is a coupling reaction between 2 aldehyde that allows the preparation of alpha hydroxy ketones. That is, in the alpha position, the hydroxyl group will form. Alpha position, that is, this is this carbon, there is carbon, so this is the alpha carbon. So hydroxyl group attached to the alpha carbon. The presence of potassium cyanide or alcohol. So 2 benzaldehyde will couple together. Similar reaction of aldol condensation occurring here. You can see that is here you can see K plus Cn minus. So the Cn minus, that is a nucleophile, attack this bond and the bond shifted here. So it will substituted here. You can see this. And in order to the stability or hydrolysis occur here, so O minus became OH. So this again, this OH minus will absorb this hydrogen. So the bond shifted here. So double bond or minus charge will form. There is 3 resonance structure will form here. In this resonance structure, again the bond shifting, bond formation occurs, and another aldehyde. So the first step, the Cn minus will attach here. So a minus charge will produce here. So in this case, there is another aldehyde. We are taking two aldehyde. So what will happen? This minus charge will attract this carbon center. So the bond again shifted, same reaction. Okay. So instead of the Cn minus, this another aldehyde group will attach. Not aldehyde group, the first compound will attach. We'll get the bond compound. In Canizzaro reaction, it is a very important reaction. Aldehyde are treated with sodium hydroxide to form alcohol and sodium salt of acid. So we have taking aldehyde treated with sodium hydroxide. So what will happen? Similar reaction only. All reactions are similar. Here we have to take two aldehyde. So we can see here Na plus and OH minus. So what will happen is, we know the C double bond here carbonyl group C double bond O is there. Similar method, this Na plus or OH minus will attack here. The bond will shifted. Similar mechanism we can see the rearrangement. So if aldehyde treated with sodium hydroxide will form alcohol and salt. Salt, that is sodium benzoate. If we are taking formaldehyde, we will get methyl alcohol and sodium formate. Similarly, up to which aldehyde we are taking, we will get the compounds. So here you can see the mechanism. So we know we are taking the base, so OH minus. The first step is OH minus will attack here, attack the carbon center, and the bond will shifted O minus. So the first step is this, and this O minus. So the second aldehyde, in the second aldehyde, this H will attack here and will get to the compound CH3O minus. CH3O minus eliminate here. So here it will attach here, O minus again shift, like that mechanism here, because here O minus will shifted here, this hydrogen will remove here. There are several type of mechanism here, and again to this one will react to give CH3OH, and from here this H will eliminate. From here this H will combine to CH3O minus, will get the compound alcohol, and so here O minus will produce. To the O minus Na plus will attach, will get salt and alcohol. There is a crossed Canizzaro reaction is also there. Benzaldehyde and formaldehyde are treating together, will get benzyl alcohol and formic acid.